Okay, thank you. Ulf Andreasson is my name, and I didn't put it up there. I realized that afterwards. But so what I was asked to do, and what we have been kind of seeing and hearing a lot about in MapR, is kind of this term that came around for a couple of years ago. What would Google do? I'll gonna touch on a couple of different things here, so it's got to be kind of a bit of a spread. But I'm also coming to the end of the presentation. I'm kind of touching on what Google is doing right now with some of these things. But you all pretty much know that, or should know that, Google really kind of came about in the way that they wanted to do a better search experience for everyone. But the way, the amount of data, the way they were doing it, you just couldn't do with traditional ways, traditional tools. You're going to have to do something different. So, I mean, big data in general is all about this, right? There's massive amounts of data. There's new type of technologies to be able to explore that data in the best possible way, or in the best possible way for you. Now, the first thing they did is kind of address the need for, like, how do I store these things? How do I handle the data that is there, that I'm kind of collecting and all that? The second thing is like, okay, how do I analyze this data? So this is pretty much basic. You've heard it, we've already heard it in some of these presentations, and pretty much anyone who talks about this is like, there are different things, storing files or storing a lot of data. If we look at Google, they kind of went into Google Mail, so suddenly they needed to have a bit faster type of storage, smaller pieces of data, and really the more we look into what Google is doing, they do a lot, and they do a lot of kind of new stuff. They invent a lot of things. Now, what then happens, or what happened with the Google and everyone else in the space, is that they wrote some papers around it. And they wrote some papers around it, and people started to implement this in an open source way. One of our founders, our technical CTO, MC Srivas, he actually worked at Google, and he literally worked there. He had one of the big research groups, 80,000 nodes in the network, 30 people working for him, and they were doing all this kind of search and looking at optimizing all these things. So the question was, when he kind of looked around, and he, now we're getting back to like 2008, 2009, and he looked at sort of Hadoop, and he saw that it was an incredibly interesting kind of thing taking place, an interesting activity taking place in the way that people implemented what sort of Google did based on the papers. Now, what he saw, there were also some flaws, there were also some issues, and basically the question is, how do you address those? What would be the best way of doing that? He was talking to a lot of people around in the space. He was talking to Hortonworks, he was talking to Cloudera, Facebook, pretty much all of the kind of big guys over in the Bay Area, and they all kind of discussed, like, how can we address the basic needs for what we need to do here. I mean, there are a couple of JIRAs which have been around for many years. Effectively, how can we enhance what Hadoop is already doing, but which would fit into what an enterprise wants to do? Not everyone is a search company. Not everyone needs to kind of crawl the whole of the internet and just store the data in files in a continuous way. I mean, enterprises tend to have some different sort of requirements. So, and MC Srivas, he's also very much a kind of file system guy. He's been working with file system the whole of his life. So he was very much looking at this from the kind of file system, from the data layer point of view. And what we sort of came about, the reason why MapR came about, is really that we kind of looked at what Hadoop can do, and we see that the most important thing you're going to have is a solid foundation. With a solid foundation, you can do a lot of other things. It's not necessarily about like who can do feature X, Y, and Z. It's more about if you have something that you can build upon, then you can build and you can adapt to a lot of different things, depending on what's happening in the future and so on. So we wanted to kind of address these things, and you know, there's a lot of things happening in the space, and there is a lot of very good things, and there are some challenges there too. So what we started doing, in 2009, when MapR-FS got founded, it was a company that was in stealth for about 2 years. They worked on providing a data platform. So effectively, a alternative implementation of the HDFS file system. Now, HDFS is just a file system, you know, as in file. But what we realized after some time is that if we can address the scalability issues, the performance issues, but we can also provide enterprise features like snapshots and mirroring and all the other things. But if we can address those, we don't necessarily only need to store files in there, we can also store tables. So suddenly we saw that, you know, and that's why we call it a data platform, not a file system. Because today, our file system, which is a compatible, both binary and API compatible to HDFS and HBase, stores files and tables in a very similar way, or at least it's presented to you in a very similar way. But it, as I said, it 100% supports the kind of APIs to address, you know. So my point here is that what bothers, or what's important for you, is not necessarily how you store it. I mean, if we can provide you with kind of good performance and the redundancy and security in how we store your data, then how, the implementation of that is not necessarily the important thing. The important thing is that you can address, you can access the data in the way and shape and form you want to do that. So what we came about to develop is actually a file system that's implemented in C and C++. It runs straight on the disk. It consumes the physical disk drive, partitions and formats, and keeps, you know, we have control of every block on that disk. We basically provide you with that data platform that, you know, gives you an API to HDFS or HBase. But what we also can do here, or actually, let me go to the next slide. From a performance perspective, because our code path is so much shorter, it's so much more distinct in what it wants to do. So when we look at latency, when we look at latency, and this is YCSB benchmark, sort of 50-50 load, 50-50 sort of distribution of reads and updates, and it's a 10-node cluster. So it's pretty basic. I mean, this you can do, and every customer we install this with is basically doing this benchmark. But the point is, the blue line at the bottom, that's our latency. It's kind of quite predictable. It's pretty stable. You know, you get latency. We were just hearing Peter talking about that. You're always going to have latency. The question is how you can make it predictable and how you can make it low. Now, when you run these benchmarks, or any kind of benchmark, you know, it's all a question of how you either store or update or read from disk, right? That's the whole thing of managing massive amounts of data or data sets. So while if you think of that, if you're going to go through Java virtual machines, you're going to go through an operating system, you're going to have a file system, you don't really have access to the disk blocks. You're an application on top of a stack of multiple sort of code paths. And if you get a Java garbage collection there, it's nothing you can do. I mean, if you run a MapReduce job, yeah, performance is not necessarily the most important anyway. It's going to take, you know, it's going to take some time to just run the job. But if you want to, and what we see today with Hadoop is that we see different execution engines. We see a lot of new technologies in kind of analyzing data. So MapReduce is definitely going to be there to stay. But Spark, there's a lot of other of these technologies, you know, Flink. There's a lot of these technologies. And then suddenly this thing is getting very important. Now, you know, Minute sort and terasort is also another one. People are running these benchmarks on a continuous basis. So basically, we had a customer who ordered 600 nodes and they only received 300, so they sort of didn't really have anything to do. And they started running minute sort in the space. So with 300 nodes, they provided much, much better performance than the previous benchmark, or the previous record, so to speak. But again, this is all sort of benchmarks. But again, the point here is that this is something that customers do on a continuous basis. Pretty much every installation we do go through these kind of exercises, because it's a good exercise for us to prove the point that, okay, we have a sound and solid installation here. So we kind of have a collection of all these customer provided benchmarks they run. The question then is like, have you run it in the right order to be able to publicize it as a benchmark? That's a different thing. But I mean, these are the things. Now, it's not just about performance. I mean, MapR is, we hear that quite often, and we say that quite often, that we have an incredibly performant implementation of Hadoop. There's no question about that. But again, it's like everything depends on what the use case you're trying to solve. But what we also have is that we have a very solid foundation of not just Hadoop. Our file system, I actually missed off a word here, it should be random read and writes. So HDFS is very much a write once, read many. You know, you collect a lot of data, you drive it down to disk, you kind of write it there. You're probably not going to change that, or effectively you can't change that. But what you have with MapR, and given that we control the disk and the kind of the whole way we handle it, we can actually support you in having random reads and writes to this file system. Not only that, when we look at it from how we store the data, our lowest denominator, which is the kind of allocation of block sizes, is actually 8K. In HDFS, you're talking about either 64 megabytes or 128 megabytes, which means that, you know, you want to optimize that. So you want to concatenate small files, you want to put them into bigger entities, and then you want to write them into HDFS if you can optimize it. Now, our allocation of a file is actually 8K, so we're perfectly fine with having incredibly large amount of very small files. So effectively, your log files, you write them straight into the MapR file system, whether you do it through HDFS APIs or whether you do it through NFS, because that's another thing we can do. Supporting small block files plus random reads and writes means that we can update small files, we can write small files with kind of a kept performance, so to speak, with a sound performance in writing through NFS. When we talk about replication, because as we know, you know, every Hadoop cluster replicates the data blocks over a number of different nodes, whatever that is, typically 3. We actually start to do replication on 16 gigabytes. So that's actually not, you know, we don't use small block sizes all the time. When we start to look at running MapReduce, and we look at kind of running on chunks or you know, whatever you want to call it, we look at 256 megabytes. So what I'm trying to say here is that the implementation of MapR is not just about performance. It's also about enabling you as a customer or you as a user to have a data platform or a file system that really provides you with something that you can kind of make use in a traditional file system or data layer type way. You know, a file system is a file system, and it tends to have a lot of expectations in it today, and that's what we're trying to provide. So, you know, coming back to this, so we absolutely support sort of HDFS. There's no question about it. The reason being here is that we want to run MapReduce and all the other ecosystem components that's part of Hadoop, right? So that one we definitely do. But as I said, you know, NFS is quite an interesting concept, because what we can do, we can take that clustered file system, we can make it available as an NFS file system, And that means that you can have all your existing legacy application running straight out of the box, putting all the data into a Hadoop file system without any changes to the applications, any kind of alterations to how you would access, how you would deal with this. You know, you basically, what our customers do today is that they mount their file systems, their application servers and log servers, web servers, onto the cluster, and they put the log file straight down to the Hadoop file system. This is incredibly interesting because what they then can do is run analytics immediately on those log files, or whatever type of data we're talking about here. So believe me or not, when I started here for 1.5 years ago, I kind of thought like, you know, NFS, yeah, okay, it's kind of nice, but this is incredibly useful for enterprises because they can put data so quickly into the cluster file system. They can then run analytics on this. Now this is kind of, you know, we're still talking maybe MapReduce. Now we start to see a lot of other execution engines. So, but this is still interesting from the aspect of like, you can either push data into as a file perspective or as a file object, or you push data into a database. But then what you can do is then take snapshot of this and run analytics. Or, you know, if you run it on real-time data, you can do that too. So the point is that MapR has a different data platform, but it is compatible, and it will always be compatible to HDFS and HBase, and we're looking at some sort of alternative APIs as well. But basically, HDFS and HBase and NFS makes it incredibly interesting for enterprises. Now, you know, we do then want to provide these other aspects that sort of typically enterprises expect from a file system or from a data platform. But I'm not going to go all the way into that. So there's a lot of other things we do as well. So, you know, given that we sort of touch on this from an architectural perspective, we removed the need for a name node server. And I kid you not, I mean, this is making life so much more simple. We effectively have a distributed version, distributed software implementation of a name node functionality, if I put it that way. But this basically means that it's a software service that we install on a number of different nodes. And if any of those nodes goes down, it will just fail over to any of the other nodes, which means that the name node is kind of the least of problems we have. We made sure to remove all the other kind of single points of failures as well. So when you have a job tracker and you've been running jobs for like 10 hours, that job tracker is failing over, but it also brings the job is done. So you're not sort of going to have to restart the jobs you're doing. And, you know, of course, we have sort of both MapReduce and Yarn. You know, Yarn is coming heavily now. So there's a lot of things to that. An interesting fact is that rolling upgrades, I mean, if you have a cluster that has a name node server, it's all well and good. But the problem is, if you want to upgrade that cluster, having that name node server is actually becoming a problem, because once every now and then you're going to have to bounce that name node server. And, you know, so that may be an issue too. So MapR supports sort of rolling upgrades in the way that we can bounce any server at any point in time, because we don't have the kind of distinction of a name node server. So there's a lot of these things, but you know, if you're interested in this, we can always talk about that at a later stage. What we also have, and I kind of touched on that briefly there, so we do support and storing files in our file system or in our data platform, but we also store sort of tables, which basically means that our HBase implementation is something that runs within the Hadoop cluster we have. Now, in the beginning, we had, I mean, you can still run Apache HBase on top of MapR as well. So if you want to do that, you can run both of them. And that's actually very good if you do migrations or if you're moving data in and out or whichever direction you go into. But It is. I mean, it's again, it's kind of what we've done here is not just about performance. It's also about making it more resilient and more simple to use. One aspect of performance is actually not just about that it goes faster to do something. It's also that what you can do is you can run a cluster with less nodes. So that's actually quite interesting, and that means that your cluster is going to be easier to maintain. But if you also remove some of the sort of requirements of running a cluster, it's also getting even easier to maintain because of that. So we've been doing some work here, and basically, you can go in, you can download the community edition, you get the pretty much everything. You can run a MapR cluster for free with all the functionality, except that you don't have HA if you run with the free version. So what we provide, moving to a paid version, is effectively the HA functionality. And from that point of view, there's we've removed the JVMs because HBase doesn't run on top of JVM here, and we also removed the notion of a master server and a region server when we talk about HBase. So basically, every node is a region server, but that's something that is kind of more of an implementation we've done, but it's nothing you need to manage. Splits and all those kind of things is either taking place automatically, or you can decide to do those too. When it comes to accessing the data, and I kind of had Dremel there, so the point we see is that we support all of these different technologies. And I apologize for not having Flink up there, but we do want to provide the best platform for your use case, not necessarily because we're sort of behind one of these projects or anything like that. But we have anything from running Vertica on top of a MapR cluster. And this is actually quite interesting, because the way they run Vertica, or the way we run Solar, or any other of these tools, is that we loopback mount that clustered file system using NFS. Then all of these traditional tools can just use that loopback mount to write the data straight into the clustered file system. The performance is there to do this. And it also means that we don't need to have any specific connectors or any specific sort of ways of accessing data through the HDFS APIs if you talk about traditional applications. If you develop your own application, you're free to use whatever API you want. But, from that point of view, if you want to run Impala, please do. If you want to run Apache Drill, although Apache Drill is not out yet, but it's kind of coming, Hive on TES, yeah. So this is all about making sure that the use case you have is being supported by the tools that are best in supporting you doing that. It's not just we saying this. We have a lot of customers. We have around 500 paying customers today. This report came out 2 weeks ago, and it basically looks at NoSQL databases, where MapR, or MapR-DB, as we start to call it, is getting a very, very good attention. From a strategy point of view, no, we don't have the kind of complete strategy. What they mean by strategy here is really about partnerships and kind of how we go to market, how we, effectively publicize this or speak about this or publicly. We are a small company. We haven't put all those things in place. We're growing, not exponentially, but we're growing very fast. So these things are coming, but we are growing. We're doubling pretty much on a half-year basis. So it's been an incredibly journey. But the point is that from a technology perspective, we have a very, very sound technology. And that's what our customers are seeing as well. Now, there was another one previous to this, which came out earlier this year. Sadly, my colleagues at marketing sort of choose to remove all the competition there, so it doesn't really tell you. But basically, what they said is that we have an incredibly good and sound product. But again, we haven't sort of been running that long, and we're not that big. We haven't got all the partnerships in place, but we're working on it, so we're getting there. Now, that's a lot of those kind of analyst companies and all that. But one thing that is interesting too, is that if you go out and you want to run Hadoop as a service, I mean, there's plenty of those out there, as in public cloud offerings. But the two major ones, Amazon and Google Compute Engine, they selected MapR to run their Hadoop as a service. And we think that's pretty amazing. I mean, out of all the different sort of Hadoop distributions out there, you can just go there, you can put your data into S3, you put your Hive job or whatever job you have, and you basically say, okay, Amazon, if you put a cluster together of 10 nodes using MapR, run this job and give me results and do whatever you want with that cluster afterwards. So basically, within a time frame of 1 to 2 minutes, they build a cluster for you, push the data from S3 into that cluster, run your Hive job or Pig or whatever you're running, and then they give you back the results in S3, and then they tear down the cluster. You pay for 10 minutes of work. That's what you're paying for. Both Google and Amazon is doing this with MapR. Now, of course, you can build your own cluster if you're going to be running on a more sustained basis. You can build your own cluster on any of these platforms or any of the other virtualized platforms as well. But this is like running Hadoop as a service. So that's quite interesting too. And of course, it means that if you're only going to be running some MapReduce or you're only going to be running some analytical work for a short time frame, you do this. You pay for 10 minutes of work and that's it. You don't need to stand up your own cluster. You don't need to kind of buy the infrastructure and do all those kind of things. So that's quite interesting too. And of course, same thing is happening with different companies using OpenStack and so on. Actually, with OpenStack is even more funny because I mean, one thing with virtualized hardware is that you are going to get a penalty. I mean, there was a questionnaire earlier today about like if you run this in the cloud, are you going to get any type of penalty for that? And yes, you typically do, because not necessarily because the memory and the CPU is virtualized, but the parts of the storage is typically virtualized, which means that your data access to the storage is going to be impacted by some kind of SAN, NAS, whatever storage that operator decided to use. So that we do see that. But OpenStack is kind of funny in the way. I mean, they've had a lot of different technologies. One project which is now seem to be upcoming is the project Ironic, which basically means that you're going to provision physical hardware using the OpenStack management. And it's kind of, if you're going to provide, or if you're going to instantiate a Hadoop cluster, it sort of makes sense because Hadoop can drive those systems so hard. So you don't necessarily want to run those on a virtualized platform. Although technically you can absolutely do this. And this is coming back to like, if you run this because of a use case, then what are your requirements for that use case? But the last thing, I think it was the last thing, yes. I kind of said in the beginning that what is Google doing? Now, this is way too much text and so on, but it's kind of interesting though, because working in a very, very small company in a area that basically was invented by Google, and Google decided to give us a lot of money before summer. I mean, it's not like they're giving, right? We're not talking about Santa Claus. But the interesting thing I feel about this, and this is not sort of my words, as you can see, but basically Google, if anyone, understands how to make use of technology, whether it's open source, whether it's in-house developed or whatever it is. And of course, Google Capital then is very strategic arm of Google investing in companies they really believe in. They've only invested in 6 companies before us. So we're not talking about like a venture capital in traditional terms. I mean, they do have that too. They do have Google Ventures. But Google Capital, after speaking to us, after speaking to a lot of our customers, they decided to kind of put their bets on us. And I think, from a mapper's perspective, that's pretty darn cool. So that was pretty much me. And if you want to reach me for any reason, ulf@mapr.com, or any of the other ways of accessing us. But yeah, thanks a lot for having you.
Thank you, Ulf. I think we have some time for questions before lunch. There's one up there, Jim.
Hi, Ulf. Thanks for your talk. So last year I talked to the head of R&D in Nokia, and he said he wouldn't buy you because you're proprietary, and the main technology that you talked about today, this very scalable HBase platform and your no need for a name node, is that, I'm looking at a presentation here from your founder, Srivas, that you wouldn't use two-phase commit, you didn't use quorum-based updates to maintain consistency of the namespace. You're using a technology called MapR lockless transactions. But there's no public information about what this is. Can you tell us anything? I know you're proprietary and you want to keep things secret, but from us as a community in big data, if we want to trust your platform, it'd be good for us to be able to know what it is.
Yeah. So I think, and that is, I mean, it's a valid question, and it comes up every time, every discussion we have, right? So I think, or the conversation we have is that it's not, I mean, we can drive it down through technology and all that. I appreciate that you kind of want to know all about that too.
But sorry, at the very basic level, we have an agreement problem, and you're presenting a solution that in the literature is completely unknown. That you're saying we can solve an agreement problem without the need for what we talk about in distributed systems as two-phase commit algorithms, quorum-based algorithms. You're saying we can solve the agreement problem without any of this.
Yeah.
Like one-phase commit or something.
So the point I want to make is that, first of all, if you trust that you're not going to get locked in, that's sort of prior number one, right? That's what everyone is asking for. The reason I want to use open source is because I don't want to get locked in. That's from a technology perspective, yeah, we can talk about how you do that, how certain things were implemented. But the main point is that you don't want to get locked in. You want to have a way out. And that's where we are adamant that if you choose to go with MapR is not more complicated to leave or to use than any of the other Hadoop distributions.
Sorry, that wasn't the point. The question was one of technology. So there are question marks about the safety of your solution, about whether this actually has the properties that you're claiming. So if you're saying that we have a distributed namespace and we're saying that the data is consistent across the namespace, and you're not telling us how you reached that, or how you maintain the consistency of it, it's very hard for us as a community to believe you.
Yeah, I mean, I can't go into all the details around that, and I'm not probably the right person to go into all those details as well, and I don't think it's the right audio, right sort of medium to do that here necessarily. But my point is still that what we're talking about in most of these discussions is that you don't want to get locked in. You want to make sure you have a way out. You want to kind of feel safe in what you select, right? How we do that later on, that's something we can discuss. But I mean, there's also patent. So it's not that it's not sort of available to see. There is a patent out for what we've been doing in MapR file system. That is available.
Is it published and available?
It is. Every patent is published and available. So it's,
okay, we have some reading to do.
Yeah, I'll point you to it. To it. But basically, I mean, yeah. So I appreciate what you're saying, right? And I was a bit kind of wondering, like, how technical should we be in this audience? And obviously, I say that we can go way deeper than what I've done today. But yeah.
Oh, good. I think, the discussion is also about maybe technology versus business here. MapR is a commercial implementation. Do you think that you have to polish it this way, or sort of to hide the technicalities for industry to pick it up? Is that what you're saying?
No, I don't think. I mean, we're not about hiding it all. We're not about sort of, the patent is publicly available. You can just go and search for it. Okay, we haven't put it on the web page. We haven't sort of distributed how we do things. There's also always a bit of like, how much do we want to tell versus how much do we want to kind of keep. The point is that from a API perspective, we support you as much as any of the other guys do. If we need to kind of see the implementation, yeah, that is what I kind of think about is that if we're religious about seeing the source code, yeah, we're probably not going to be for you, right? We're not going to open source or show you all the source code we have. But that's not the point of what enterprises want to do today. Enterprises want to get into the big data space. They want to do more advanced analytics. That's not, I mean, I was working in the operating system space in like 2000, 2005. Linux was kind of coming heavily. You had banks in the UK who was developing organizations of just developing a Linux distribution. I mean, that's not the core business of what enterprises are doing today. And they didn't do it then, but it sort of became something that everyone was doing after a while. So I think it's getting down to like, how core is this for your business? What is it you really want to focus on versus what is it you really want to kind of do? As in, do we want to run analytics or do we want to run a Hadoop cluster?
Yep, sounds good. And any questions more from the audience? Safe? I have one question up there too. You want? I'll take it with you first.
I think what Jim wants to say is that for users, and could be commercial users, they want to trust your system.
Yeah.
And they cannot trust your system. It's not a question of code. It's just a question of the method you achieve certain properties of the system. That's what...
yeah.
Because they don't want to run critical application and the system really does not satisfy some consistency condition. So that would be very critical for them. That is the point that Jim wants to make.
So, and I understand and I appreciate. No.
So let's maybe we'll take that discussion offline during lunch. But I think we have one more question.
How are you? And I would like to ask a question. Compare with Peter's presentation and yours. And if we move more and more data to the cloud edge, to the edge of the network, and what is your idea of MapR to process this? Or do you have any solution to process? If not, if you do not have, what do you think about the challenge of this trend? Thank you. Okay,
so if you go back a year or 2 years or whatever, I would say we're very much in the data center. We kind of very much a batch oriented solution. You put all your data there, you start to do analytics. It was very much at the back of the data center. Now, what I've seen during this last half year to year is that we are taking leapfrogs to working much more with real-time data, streaming, real-time, whatever you want to label it. But MapReduce is always going to be there. But what we start to see is, we're discussing quite a lot with regards to Lambda architecture and kind of how you effectively store all the data in an immutable way to be able to do the kind of historic trending and analytics. But you also start to run real-time analytics on the data coming in. And at some point in time, you may be doing sort of a combination of the two, or you have, you create reports of both of those streams, or you make that data available, or the results of the analytics available. And then it may depend on some of it's maybe done on sort of older type historical, long-term views, while some of it is really kind of up to the limit. Or up to the minute sort of analytics. So when we come into this kind of new way of working on real-time data, then we're certainly hitting the kind of challenges that Peter was talking about. And I think is actually quite interesting. Now, the only question I have is that my son is never going to leave his big laptop, or big, desktop for, £1,000 or whatever it costed when we bought it last. He's not going to do it on a mobile phone. But just wait 10 years. Exactly. That's the point. I mean, he's at some point in time, but it probably will be his kids or whatever. But it's I don't know, to be honest. It's interesting because more and more, and the whole sort of Internet of Things and all that's going to be exploding into this, and there's going to be something we're going to have to do about it.
Good, thank you. I think we have time for one more question if somebody has one. One thing I guess the last question is also I'm wondering, I mean, we're talking about MapReduce a lot now, going back to that, and we also heard about these extensions of MapReduce. And the title is, what would Google do? Do you think Google, if they started over again, actually would look more towards these extended versions of MapReduce?
Yeah, I mean, Google has, they still do a lot of MapReduce, but they have sort of gone far from kind of Dremel and Bigtable, and pretty much a lot of things they do today is all in big tables. I've been talking a lot to Srivas about what we're going to do in the future and so on, and he's got a lot of ideas. I mean, he's been in Google for a long time, so he knows, but he's not allowed to kind of say too much and all that. And but there is a lot of things. I mean, what we see imminently is using MapR-DB or HBase together with technologies like Drill, so effectively Bigtable and Dremel. That's what we see imminently now. Because what is happening big time is that everyone wants still to run SQL, but they want to run SQL on the kind of big data platform they have. So Drill, I didn't speak much about Drill, but Drill is very interesting because that's really kind of schema on the fly or schema on the run. So you don't effectively need to define any kind of schema at any point in time. You just basically point it to the data, and it's going to be self-exploring of the schema, and the schema may be changing while you actually look at the data. And so, SQL-on-Hadoop is something that's coming big time, as well as kind of all the different execution engines like Spark and Storm and sort of Flink and so on. That's coming big time. There's no question about that.
Well, again, thank you, Ulf.
Okay, thanks.